All right, the second part of this lesson is simplifying compound fractions, which kind of puts everything together. It's a whole bunch of just getting common denominators. So for this first example, if we just look at the numerator, we need to get a common denominator here. And in order to do that, this left half needs x plus 1 over x plus 1, and this right half just needs an x and an x. And then that gives us a common denominator of x times x plus 1. And in the top, we have x plus 1 plus 2x, because this 1 just distributes to both parts. So simplifying just the numerator, we're still just working with the numerator, is 3x plus 1 over x times x plus 1. All right, so we have that part just for the top part. Then, so our top part is 3x plus 1 over x times x plus 1 all over 1 over y. In order to get something out of the denominator, you multiply by the reciprocal. So we're going to multiply by y over 1 and y over 1. And when we do that, everything in the denominator cancels nicely, and we're just left with 3x plus 1 times y over x times x plus 1. It does not look pretty, but that is our final answer. So you can box that, and you're done. You're good to go. That is what I would say the easiest way to do these types of problems. And I think that's kind of helpful. So anytime you have a compound fraction, again, we could have something, this is just another example for your notes. Just make sure anytime you have something in the denominator, you would just multiply by the reciprocal to get it in the numerator. Then you'll see everything cancels. So just something like that. That's the hint there. The next thing we have is find a rate. So Leah drives her car to the mechanic, then she takes a commuter rail train back to her neighborhood. The average speed for the 10-mile trip is 15 miles per hour faster on the train. Find an expression for Leah's total travel time. If she drove 30 miles per hour, how long did this take? So if we were to set up a table for this sort of problem, distance equals rate times time. You've probably seen these before in physics. Distance, rate, time. So we're going to do this. Distance, rate, and time. And we're going to do the car, and we're going to do the rail. All right, so we know that it is a 10-mile trip no matter what. And we know that the rate of the car, we're just going to call R. And we know that the train is going to be R plus 15 because it's 15 miles per hour faster. All right, and so our time is just going to be 10 divided by R, or 10 divided by R plus 15, because distance equals rate times time. So if I needed time, I would just do distance divided by rate, which is how I got these last two things, distance divided by rate. So the total time for the trip is just going to be 10 over R plus 10 over R plus 15. And then you just need to simplify that. So getting a common denominator, this side gets an R plus 15. This side gets an R plus 15. This side just gets an R and an R. So you end up with 10R plus 150 plus 10R all over r times r plus 15. Simplifying that, you get 20r plus 150 over r times r plus 15. All right, so we know we're driving at a rate of 30 miles per hour. So just plug in 30. 20 times 30 plus 150 over 30 times 30 plus 15. Using your calculator, you get 750 over 1350, which reduces to 5 over 9. So the total time is 5/9 of an hour, which is about 33 minutes. So that's a little challenging. The most important part is to remember distance equals rate times time and being able to set up a table. Once you get that, it's not too bad. There's a couple you tries down here. I'm going to go through one with you. I guess I'll go for this first one. The numerator is already simplified, so I'm going to work with the denominator down here. X plus 1 over 3 plus 4 over x minus 1, and I need to get a common denominator. This guy on this side needs an x minus 1 over x minus 1. This guy over here needs a 3. So it gets multiplied by 3 over 3. So then the common denominator is just 3 times x minus 1. In the numerator, if I FOIL, I actually have a difference of squares, so I end up with x squared minus 1 plus 12. So in my denominator, I now have a problem that looks like this. Making sure I didn't make any mistakes here. This needed an x minus 1, x minus 1. This needed a 3 and a 3. So FOIL that, I get x squared minus 1 plus 12. Okay, so I've got rewriting this as the denominator now. I come to this next thing right here. 1 over x minus 1 over x squared plus 11 over 3 times x minus 1. And in order to now get this in the numerator, I am going to flip it, write it times 3 times x minus 1 over x squared plus 11. Same thing down here. I'm just flipping it so the numerator will have the reciprocal, and the denominator, everything will cancel, but technically I'm multiplying it by 1 because anything divided by itself is 1. So now I am just left with 3 times x minus 1 over x minus 1 times x squared plus 11. Nicely, my x minus 1's cancel, and I'm just left with 3 over x squared plus 11. That is my final answer. If you want to work out b on your own, you get 2x minus 1 over x squared plus 2. So go ahead and see if you can do that on your own and end up with that answer. Also, if you want to work on an extra word problem, we'll probably go over this together, but the total travel time formula when you make your table ends up being this. So you can check that out and see if you get it. You could also have this in factored form, 20 times 2r plus 5 over r times r plus 5. So nothing cancels, but that's where you make the table, do distance equals rate times time, just like I did before, and you should end up with something similar. All right, good luck.